Hi everyone, and welcome to this Careers in Robotics session with Associate Professor Jun Jo from the School of ICT at Griffith University. Jun is the Director of the Griffith Robotics Lab and the Programme Director of the Bachelor of Intelligent Digital Technologies. If you have any questions during the session, please type them in the Q&A section on your screen and Jun will answer these at the end. We also have a feedback form, if you could please fill this out at the end of the session. With that, I will now hand over to you, Jun. Oh, Jun, if you could please just turn on your mic, please.
Oh, can you hear me?
That's great, thank you.
Okay, thank you. Hi, everyone. My name is Jun Jo. I am the Program Director for Bachelor of Intelligent Digital Technologies, which is one of the first degree programs in the cutting edge areas in the world. So I'm very proud of the new degree, what Griffith University is offering, and you are very welcome to this new field. So today I'd like to introduce the new field, and especially many of the students may heard about a lot of the new technologies, and perhaps they are not very sure which area they have to go. So hope I can give you some clear idea which area is the best fit to your interest and your talent. So if I briefly introduce myself, I studied basically artificial intelligence and knowledge-based design systems at the University of Sydney. And currently my main research areas include machine learning and image processing. And we apply these kind of technologies to many robotics, IoT, including satellites, drones, and MRI images, which is medical images. Currently I am the program director for new degree, and I am leading the Australian Robotics Association, and we are having some international organization, which is World Innovative Technology as well. Okay, so when we say robots, then many people think about human-like robots. The intelligence is similar to human, looks like human. But robot has got actually more than that. So it's a little bit noisy, but robot has something far beyond what human can do, while something what human can do, robot can't do. So these days, robots technologies, they no longer try to make robot like a human, but based on the advantages of computers and machines they have, we are gonna develop. We are developing many interesting machines and apply to many areas. So as you see here, if you go to small companies in factories in most of the countries, you will easily see these kind of small robot arms, which can move heavy things, or they can very accurately the solder or screwing and so on. And on the right hand side, as you see, there are many medical applications of robots, which helps disabled or someone has got little difficulties to move. So these actually images are really quite old one, but people, they developed many useful gadgets and applied to, particularly in defense or military, helping moving very heavy stuff, especially through very dangerous areas. So the other one, Wildcat, is very fast moving robots, also very useful for moving heavy stuff. So as you see here, the robots are nowadays is very stable and very strong and fast as well. Of course, we have many drones which flies and then monitor or carry some things. Sometimes they use it for military purpose. In the medical area, I think robot is very useful, especially for Australian environment. So in this picture, we call it Da Vinci set. And in here, actually, only one person is a doctor, which is sitting on the and holding the joystick on the left-hand side. Right-hand side, usually they are a nurse and technicians. So the doctor can do operation by looking through the screen and by moving the joysticks. And the more interesting thing is that they can work together collaboratively. So they don't have to be at the same place where the patient is. So one person can be in America, another one in Sydney. Maybe the patient can be somewhere far inside the Australia. So this device allows sort of remote operation by combining, special doctors from many different places as well. So it is actually there are a lot of remarkable development is going in medical area. So robotics is kind of multidisciplinary areas. So that involves control, artificial intelligence, information and communication technologies, electronic engineering, mechanics, computer vision, and so on. Actually, not only those, but there are a few more. And you can't basically do everything. So perhaps you have to think which area you are particularly interested in, whether you are interested in building sort of mechanical structure, then maybe you can choose the mechanical engineering. If you're interested in the electrical or electronics, then maybe you can choose EE. Or other areas, particularly what we are strong at, artificial intelligence, information and communication technologies, control algorithms, computer vision. Those areas is what our School of ICT at Griffith covers. So nowadays, perhaps autonomous vehicle could be considered as a robot, and then that is kind of integration of all those different specialties. So nowadays, the robot is not just a single unit, but they have started being connected each other. So IoT, in other words, Internet of Things, are getting popular, and nowadays we consider robotics and Internet of Things together. So one of the majors of Bachelor of Intelligent Digital Technology is robotics and the Internet of Things. So what this one does is that all the objects around us will embed small, tiny robots, and then they can start talking each other and make our life very easy and very comfortable. For example, these days, an ordinary house has got at least 40 to 50 microcontrollers unit or small robots. For example, your watch, something like this one, or remote controller, TV remote controller, TV, microwave, refrigerator. Almost every electronic stuff, even toys have the small robot inside, but they just do only specific function independently. But in the future, they will start talking to each other because each unit will have a certain amount of intelligence. Actually, it is not future work. We already have a lot of development now. And then they will make our life very easy. So what happened, for example, I finished my work and I'm on my way home. Then I don't have to actually, do anything. My car knows I'm going home, so my car will talk to my perhaps computer at home or rice cooker home, and then rice cooker start cooking, and they let other microwave or all others know that I'm arriving in 10 minutes. And then just 2 minutes before my arrival, perhaps it will turn on all the lights and then so on. So Internet of Things are very, very useful technologies for our future. Now, most of the countries, including Australia, set this fourth industrial revolution as the key sort of future technologies. And then they invest a lot of money. So perhaps you heard about the first industrial revolution, which is mechanical revolution. And they started using water power, steam power. Second industrial revolution is about mass production, so that the machines can produce the same products over and over and reduce production cost a lot. Third one was about computer and automation. Now we are in the fourth industrial revolution, which contains cyber physical systems. Means that it is not just faster computers or more storages, but it allows robots, artificial intelligence, UAVs, IoTs, everything integrate together and make them communicate each other and change our life a lot. Now, last night, I actually searched the internet and tried to find out how much salary for robotics. So as you see here, the currently average the salary is about $81,000. I think it's American dollars, as you see here, US, per year. So which is larger than or more than the controls engineer and automation engineer or similar areas. IoT, as you see here, 101,000. So this one is just the general junior staff salary. If you become a senior, like here, then you will get more than 140 or $50,000 easily. Actually, this morning I met one investors in this area, and he said that one of the students recently got work in Internet of Things, and he gets about $300,000 per year from Google. So there are a lot of opportunities earning high income these days, and then the opportunities will increase more and more. Okay, so what can I study to become one of these robotics or IoT experts? School of ICT provides and has been providing basically two major degrees. One is computer science and another one is information technologies. So perhaps you know about those, the difference between those two, but if I explain it, Bachelor of Computer Science study requires some basic mathematics knowledge, even though it is not too much. And then you will learn how to program and make software, for example. So it requires a mathematical background and good skills in programming. Whereas Bachelor of Information Technology, we don't require too much programming skills or mathematical background, but we teach you how to use and provide excellent service to the clients using web technologies, database, cybersecurity, and so on. Now we introduce new degree program, which is Bachelor of Intelligent Digital Technologies. And then what this one does is that it is kind of innovation or innovative concept is more important. And then you can, produce a lot of applications for new futuristic gadgets like drones or digital watch, game machine, smartphone, and so on. So this new degree requires, rather than software skills, requires more innovative and creative concept. So these are some examples what you can program directly. So now they staff, taking our lives like autonomous cars or drone-based delivery system, or digital watches which can check our health. The middle one is actually diabetes checker on the right-hand side. You can even use medical, which is ultrasound, scanner connected to your mobile phone. It is already, commercialized. So this is, what we have so far, but we don't know what will happen next year in the future. And there's what you can create after this degree program. From here, I'm going to show you some of student work done. So um, you can see what you can do. Actually, we don't teach everything what you see here, but we teach you some basic skills and sort of some basic knowledge how you can utilize the technologies available around us and then produce. So we have one autonomous car on the top left, and on the top right, we practice it in the lab using toy cars. Both the bottom one, we use actually mobile phone. As you see here, our mobile phone can guide your autonomous car. So mobile phone can detect lanes and obstacles in front. So bottom left is sorry, daytime and nighttime. So the cameras are very sensitive about lighting conditions. Even shadow can affect the accuracy a lot. So our students understand those kind of illumination sort of problem. So you can develop a very intelligent and accurate navigation systems even using your mobile phones. So this example was done by one of the honors students. So he using smartphone or USB camera did extract some features of certain face and then distinguish the face from others or objects as well. This is another example. So two different faces, and then you can identify two different faces. This example, even you can easily make the behavior extraction program, which means that maybe you can disguise your face and then with some mask, but you can't actually hide your behavior pattern. So this program, also student work, can easily detect who he is from, even from 100 or 200 meters apart. If there are so many people in a crowd, the program can extract individual behavior pattern and identify who is who, even though the camera cannot analyze every faces, even from the back. So this is another example. If there are multiple faces, the camera can distinguish different people and then identify them. So this example, the CCTV on the street, actually it is another kind of a robot. So CCTV can detect human, of course, behaviors, but also faces here. So for example, if you have any cleaner in Australia, the basic pictures will be extracted and then shared with all other CCTVs, not only in Australia, but all over the world. So these kind of technologies can make our society very safe. And all this kind of thing is based on the robotics and IoT concept. So yeah, so when I studied my PhD, we needed about 20 or 30,000 lines of codes to make a very simple function. But these days, you need only 10 or 12 lines of codes, because many of the functions were developed already by Google or IBM or many giant companies, and they release it open it for free, so that you don't have to make those kind of complicated programs, but you can learn how to utilize those kind of functions made by very advanced companies, and then you can easily make these kind of programs. So again, I remember this program had only between 10 and 20 lines of codes. So now they programming to make intelligence agent is very easy compared to 5 or 10 years back. And so I believe that I mean AI or machine learning, those areas were have been developed a lot, but the robotics and IoT are the next step. So they will change a lot every year. So this algorithm, same algorithm can be applied to movie. And then as you see here, even inside the car or even inside the window, the machine learning can detect the some object and even identify who he is, or so on. So these kind of technologies can be used for surveillance, but also military or defense very much. This is another student's work. We used the AR drone. We purchased it from Harvey Norman, and then we hacked the program inside the drone. And as you see here on the top, this is what drone can see through very small pinhole camera, and detects one face. And then the drone is programmed to follow the target objects living about 3 meters apart. Now, the thing is, if I just go out of this lecture room, then drone cannot follow me anymore. But drone can, because drone communicates with all other CCTVs around this room. So drone can send out this the feature to the CCTV outside, and then CCTVs outside can take the job over, and then chase the target object. So there are lots of interesting ideas you can develop and apply. This is another example. We worked for a company. So the number here is probability. So the probability of car is 96.62 and so on. So we developed some AI program, and then apply it to drone, and drone can monitor what kind of cars are passing by. So again, you can apply it to defense, and then you can detect any illegal sort of intruders and so on. This is another project we've done. So as you see here, this one is actually drones, the view from drone. And on the top right here, it shows that how many sedans, how many buses, how many trucks, how many cars, sedans in the scene. So there are many applications you can make. This one also pretty easy to make. Our students actually scanned the Google map and then find out how many airplanes in each airport. So, this one actually, I forgot to link the video, but what this one does is that this one detects any abnormal behavior of a car. So if there's any drowsy driving, or any moving backwards, no, wrong way, the CCTV in the highway can easily pick up. This one is within our campus, so drone flies, and on the top left is what the target object I gave, the job gave to the drone, so drone can easily find out the thing. Our students also play with robot fish. We have 5 robot fish in my lab, so students can program and develop robot fish. It is not intelligent enough yet. We often work with Peking University in China, and so we train the robot to balance by using machine learning techniques. So even without coding every detail, the robots use artificial intelligence techniques to balance, and then so this is another. This one has got a lot of application areas. As you see here, we have many drones available in our lab, so students can work on drones for their projects or assignments. Top right, this is what the drone can scan using so-called LiDAR or laser scanner. So a drone can fly above a city, and then using LiDAR scanner, it can build up some 3D map from the sky.
When the beat starts,
some students, they do drone dancing and appear on Channel 9 News. We also have glider type of drones. So as you see here, you can give waypoints in the map. Then the glider goes there and then take a picture at each waypoint. This is very useful to monitor a wide range of field, especially the agriculture. I have been doing many interesting, challenging projects, such as breach inspection, crack detection, or gas pipeline monitoring system, and the students are involved, and then they practice their knowledge. So gas pipeline, for example, in Queensland, we have about 600 kilometers length of gas pipeline. It is very hard to monitor, but by using drone and the sensors, you can detect any leakage or any rotten parts. We have some experts on hyperspectral images. So as we see here, human can see only the green part, which is between about 400 to 700 nanometer range, which means between the red to purple. But above, which is ultraviolet, or less than the red, we call it infrared. So even though we can't see, some camera can catch different wavelengths, and then we can interpret it for many purposes. For example, both look the same, but one is real, another one is fake, and even though they both look the same, they emit different wavelengths, so that we can easily identify them. When we apply to agriculture things, the well-ripen fruit and not well done, they produce different wavelengths, and then you can make some robot for agriculture and so on. So maybe we have a few more minutes to go. So we also have satellite image processing. So I am actually involved in many satellites, and particularly our new head of school is very expert in space technologies. He has been with NASA more than 7 years, and then we have very ambitious plan to send satellite to the space. So some of my research students will be involved in this project, definitely. So we analyze different wavelengths from the images, and then, we can detect many like bushfire or flooding or pollution and so on. This is actually one photo, sort of one scene actually, but there are 16 different channels. So even though human eyes can see one same scene, different wavelengths can detect different aspects of the same scene. So it provides a lot of information what we can't see. We also do some medical image processing, but perhaps if you're interested in, maybe we can discuss it later. Some of our successful graduates. So one guy is with Apple in Silicon Valley, Amazon, Atlassian, IBM, SoftBank, PHP, Boeing, and some academic professor and so on. So we produce a lot of successful graduates so far. So this is the end of my presentation. So I hope you enjoyed, and hope you got some good idea from this. Okay, so I'm gonna switch it to here. Okay. Okay, so I got one question. What subjects is required to study and obtain a career in robotics? Okay, again, robotics has many different fields. So if you are interested in particularly our areas, artificial intelligence, IT, and image processing, mathematics is preferable, but it is not compulsory. So if you are still a high school student, then I would recommend you to look at some basics of mathematics. But frankly speaking, even without mathematical background, still you can do. But maybe the range of the possible areas you can do is a bit narrower than others. So I would recommend you to study mathematics more. And the more important thing is innovation. So innovative ideas. So spend more time to read books and then think about and watch carefully about the objects around us. And what would happen if, for example, my bicycle can communicate with my, garden, some stuff, then maybe it can give you some interesting idea of some innovation. So those kind of things is very important. So innovation is very important. If possible, study mathematics more.
Thank you very much, Jun, for your great presentation, and thank you to everyone who has joined us today. So any further information about our ICT programs you can find on the Griffith University website. And just a kind reminder, if you haven't already, just to fill out that feedback form, just takes a couple of minutes. Thank you again for joining, and thank you, Jun.
Thank you very much, everyone. Thanks, Megan. Thanks, Tri.